Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to start new chapter S block elements. This is the third chapter of part 2. S block elements. Last class I have finished hydrogen completely. Now I am going to start S block elements. The S block elements of the periodic table are those in which the last electron enters the outermost s orbital. As the s orbital can accommodate only two electrons, two groups, group 1, group 2 belongs to the S block of the periodic table. Already I have finished the periodic table in details. Now you know this classification of elements in group wise. Then group 1 and group 2 comes under the S block elements. Group 1 of the periodic table consists of the elements lithium, sodium, potassium, rubidium, cesium and francium. They are collectively known as the alkali metals. These are so called because they form hydroxide. That's why they are called alkali metals. On reaction with water, when these elements reacts with water, then they form hydrocarbons. Okay, they form hydrocarbons on reaction with water, which are strongly alkaline in nature. The elements of group 2 include beryllium, magnesium, calcium, strontium, barium and radium. Here you should know that group 1 last element francium and group 2 last element radium both are radioactive. Okay. These elements with the exception of beryllium are commonly known as alkaline earth metals. Here in group 2 I am talking about these group 2 elements with the exception of beryllium. Question is asked, exception of beryllium are commonly known as alkaline earth metals. Beryllium is an exception. Okay. Group 2 metals are called alkaline earth metals with exception of beryllium. They are so called because why they are called alkaline earth metal? These are so called because their oxides and hydroxides are alkaline in nature. Oxides also and hydroxides also. Both are alkaline in nature, and these metal oxides are found in the Earth's crust. That's why it is called alkaline earth metals. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium, cesium have much lower abundance. Okay. Francium is highly radioactive element. Francium, group 1 last element, francium is a highly radioactive. Its longest lived isotopes, I am talking about the isotopes of radium. Its longest lived isotopes, that is the francium 223, francium Fr 223 has a half-life of only 21 minutes. its half-life is 21 minutes only. Question is asked. Of the alkaline earth metal, calcium and magnesium rank 5th and 6th. Okay, ranking wise their abundance is 5th and 6th in abundance, okay, respectively in the earth crust. Strontium and barium have much lower abundance, very less, very less. Beryllium is rare. Beryllium is rare, and radium is the rarest of all, you can say, comprising only 10 to the power minus 15% of igneous rocks. It is found in rocks, but it is very less. 10 to the power minus 10%. 10 to the power minus 10% of igneous rocks. Okay. The general electronic configuration of S block elements is you can say noble gas configuration, and in the end NS1. Noble gas configuration, and after that NS1. This is for alkali metals. And noble gas configuration NS2, and the last NS2, that is the last orbit 2 electron for alkaline earth metal. Here N is the number of orbit. Okay. Now again further, lithium and beryllium. Lithium from group 1 and beryllium from group 2. The first elements of group 1 and group 2. Lithium is first element of group 1 and beryllium, that is the first element of group 2. This lithium and beryllium respectively exhibit some properties which are different from those of other members of the respective group. They differ from the other members. In these anomalous properties, they resemble the second element of the following group. Okay. Thus, lithium shows similarities to magnesium. Question is asked. Okay, lithium actually anomalous behavior. Question is asked. Then lithium shows similarities to magnesium and beryllium to aluminum in many of their properties. Keep in mind, remember always, lithium shows similarities to magnesium and beryllium to aluminum in many of their properties. You know that aluminum is from third, okay, other group, and magnesium is from the second. Then lithium, which belongs to first, it is similar to magnesium. Its property is similar to magnesium, and beryllium is similar to next, you can say, group, that is a metal group, that is the aluminum. This is called actually anomalous behavior. Okay, that you will read separately. This type of diagonal, it is also called a diagonal relationship. This type of diagonal similarity is commonly referred to as diagonal relationship in the periodic table. The diagonal relationship is due to the similarity in the ionic size, and this is why does it happens that this happens due to the similarities in ionic size or you can take charge by radius ratio. Charge by radius, okay, ratio of the elements. Monovalent sodium and potassium means group 1. Monovalent sodium, mono means one charge, monovalent. Monovalent sodium and potassium ions and divalent magnesium and calcium ions are found in large proportion in biological fluids in our body. From the group 1, sodium and potassium are found in more, and from group 2, magnesium and calcium are found in large proportion in biological fluids, means in our body. Okay. These ions perform important biological function such as maintenance of ion balance and nerve impulse conduction. In our body also current flows. In our body also in nerves current flows. Then for this these elements are responsible. Okay, because they are charged. Ion means charged. Then they maintain these functions. Means I am talking about the ions. Potassium ion, sodium ion, calcium ions, magnesium ions perform important biological functions such as maintenance of ion balance and nerve impulse conduction. Okay, this I have told you. Now I am going to tell other things. Group 1 elements, alkali metals. We now will discuss more about the group 1 elements, that is alkali metals. The alkali metals show regular trends in their physical and chemical properties with the increasing atomic number. As the atomic number will increase, their properties will change. Okay, this is the regular trends. They will change. This alkali metals show regular trends in their physical and chemical properties with the increasing atomic number. You should know that properties depend upon the physical properties and chemical properties depends upon the atomic number. The atomic physical and chemical properties of alkali metals are now I am telling you. First, you understand electronic configuration. Electronic configuration is responsible for physical and chemical properties. First, atomic number. In that also electronic configuration. It will tell many, you can say, chemical and physical properties. All the alkali metals have one valence electron. First things, NS1. Okay, means outside the noble gas core. Outside the noble gas core. The loosely held S electron. Here, outermost orbit only one electron is there in S orbital. The loosely held S electron in the outermost valence shell of these elements makes them the most electropositive metals. Most electropositive metals. They readily lose electron to give monovalent M plus ions. Hence, they are never found in free state in nature, because they are quickly they will lose and they will combine with others. Hence, they are found in, I can say, combined state. Combined state. They will not found in free state like atoms. Only atom form it is not found, because they can lose the electron very easily. Hence, it will combine with other elements and it is found in combined state. They means quickly they readily lose electrons to give monovalent M ions. After losing the electrons, they will form monovalent metal ion. Hence, they are never found in free state in nature. Okay. And already I have told you that this thing's electronic configuration, but for common I am telling lithium. What is the atomic number? Then here lithium atomic number is 3, atomic number 3. Then what will be the electronic configuration? 1s square 2s1. Like that way, sodium has atomic number 11. Then 11, what is the electronic configuration? Then 1s square 2s square 2p6 3s1. Always it will come one element in the last, like potassium 19. Then 19 will come 1s square 2s square 2p6 3s square 3p6 4s1. Like that way, other elements, rubidium, cesium, francium, they will follow this thing off-above principle in you can say in electronic configuration, how electron will be filled, then they will fill according to the off-above principle. Okay, but in the end, every time one electron will be in the last. As for example, rubidium last electron will be 5s1. Okay, potassium last electron is 4s1. Then next is rubidium Rb. Then its last orbit is 5s1. And next is cesium Cs. Then its last electron will be 6s1, 6 orbit. Like that way, francium Fr, radioactive, its last element will be 7s1. Now I will talk about the atomic and ionic radii. Radii means radius. The alkali metal atoms have the largest size. Just now question is asked. Many questions are asked from this question, this chapter. Then be careful. The alkali metals atom have the largest sizes in a particular period of the periodic table. With increase in atomic number. As the atomic number in a group will increase, size will increase. The atom becomes larger as the atomic number will increase in a group. The monovalent ions means M plus, capital M plus, M means metal ion, are smaller than the parent atom. As for example, sodium Na plus. Then you know that due to the one electron new orbit is opened. Hence, if it will lose the one electron and it will form Na plus, then its size will decrease. Size will decrease in comparison to the sodium atom. Sodium ion will be smaller than sodium atom. Like that way, you can say lithium also, that will be smaller. Lithium ion will be Li plus will be smaller than Li. Like that way, potassium also, potassium ion will be K plus will be smaller than K. Okay, because outermost orbit will close and then automatically size will be smaller. Means ions will have, cation will have, in group 1 I am talking about, in other also, particularly in group 1, that ion will have a smaller size than their parent atom. The atomic and ionic radii, the atomic radius of atom and radius of ion, that is called ionic radii of alkali metals increases on moving down the groups. Okay, the atomic and ionic radii, both of alkali metals, increases. Obviously, because atomic number is increasing, size is becoming more. That's why the atomic and ionic radii of alkali metals increases on moving down the group. That is, they increase in size while going from lithium to cesium. Now come to the ionization enthalpies. Already in general we have discussed in the periodic table when I was discussing. Again many things will be repeated here because now group wise you are studying the properties of elements group wise. Now ionization enthalpy means ionization energy. The ionization enthalpy of the alkali metals are considerably low and decreases down the group from lithium to cesium. Now reason you are understanding, because size is becoming big and bigger as will go from lithium to cesium. Then they will be far from the nucleus. They will be far from the nucleus. Nucleus effect will be less and the last electron of the last orbit. Hence, easily it can be removed. Less energy is required. Less energy will be required in removing the last electron of the outermost orbit. Okay. Then this I told you decreases down the group. Ionization energy decreases down the group from lithium to cesium. Why? Because the effect of increasing size outweighs effect of increasing size is increasing, outweighs the increasing nuclear charge. Nuclear charge will not increase as much as you can say this thing's size. Okay, this is because the effect of increasing size outweigh the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charge. Okay, because many, as will go down, that many electron will be there in different orbit. As will go down, then they will screen it. They will behave as a screen, and nuclear charge will be, nucleus effect will be less on the outermost. That's why energy will decrease, ionization energy will decrease. Okay. Now hydration enthalpy. Hydration enthalpy. Here you can see the hydration enthalpy means water, H2O, water molecule, you can say every element, they have capacity to absorb the water molecules. Then during the when they will absorb H2O, then they will release energy, and that energy is called hydration energy or hydration enthalpy. The hydration enthalpies of alkali metal, you can say ions, decreases with increase in ionic sizes. Okay, means lithium has most hydration energy, highest in group, than sodium ion. Sodium ion is greater than potassium ion. Potassium ion is greater than rubidium ion, Rb, and Rb is greater than Cs, means cesium ion. Okay, because now I told you that in lithium, why it is highest? Because lithium nucleus, that and outermost, they are very close. Only this last electron, lithium, that 1s squared 2s1, then they are close to nucleus. Hence, they will not allow to lose easily that electron. outermost, because they will be attracting. Nucleus is positive charge, it will be trying to attract. And anyhow, when it is that electron it is losing, when H2O will come, that time it will lose more energy. That's why hydration energy is more for lithium ion. And other due to the screening effect, you can say there will be little far more orbits will open, then they will be far from the nucleus, then nucleus effect will be less on the last orbit electrons. Then here I told you lithium is greater than sodium, sodium is greater than potassium, potassium is greater than rubidium, rubidium is greater than cesium. Lithium ion has maximum degree of hydration, and for this reason lithium salts are mostly hydrated, and it forms lithium chloride twice H2O. Lithium chloride twice H2O is common. Okay, now come to the physical properties of alkali metal. All the alkali metals are silvery white. It looks like a silver, silvery white, and it will be soft and light metals. All the alkali metals are silvery white, soft, light metals because of the large size. Because of the large size, these elements have low density because size is increasing. Okay, a mass will be not increased like in comparison to the size. Okay, because of the large size, these elements have low density, which increases down the group from lithium to cesium. Okay, they have low density, but this density will increase. Low density which increases down the group from lithium to cesium. You know, density is equal to mass by volume. Then because number of electrons is increasing, then obviously number of protons will also increase. Then and size is also increasing. Then that's why as the size will increase, density will increase. In the beginning it will be less. Okay. Then mass by volume will increase. My mass is also increasing, but they are not increasing in the same ratio. Okay, that's why density will increase as will go down. Now next things you understand that potassium, but here important things, potassium is lighter than sodium. Okay, here you should understand it is exception. Question is asked. Potassium is lighter. It should be heavier than sodium, because sodium then potassium. Then potassium should have got more density, but it is not like that. Potassium is lighter than sodium. Always anomalies or exceptional things you keep in mind. Okay. Then here I am telling you potassium is lighter than sodium. The melting and boiling point of the alkali metals are low. Both melting point and boiling points of the alkali metals are low, indicating weak metallic bonding. Low means weak metallic bonding, means all sodium atoms are joined by a weak bond, or all other metals, potassium, rubidium, cesium, they are joined each other by, you can say, because there are many atoms will be there, many atoms of sodium will be there, many atoms of potassium will be there, many atoms of alkali will be there. They are joined to each other by a bond called metallic bond. Then that bond is weaker bond. Okay, weak bond. That's why their melting and boiling points are low. This is because the heat from the one more thing here you should understand. First, I told you that boiling points and melting points of the alkali metals are low, indicating weak metallic bonding due to the presence of only a single valence electron. Because they will bond will be only one electron are taking, you can say, part in bond formation. This is because that in bonding only one electron is taking part. That is single valence electron is taking part in bond formation. And the alkali metals and their salts impart characteristics color to an oxidizing flame. There are two types of flame. One is reducing flame, other is oxidizing flame. In a lab, you will see burner will be there, Bunsen burner. Then there, if you can say hole is opened, there one hole will be there in Bunsen burner. Through that air will pass, means oxygen will pass. Then you will see blue type of light. It means it is oxidizing flame. If you will close that hole, there knob will be there, means you can close it and open it. That facility is there. Then if you will close it, then oxygen supply will be very, very less. And fully it will not stop, because if oxygen will be not there, then this will not, anything will not burn. But here actually gas burns. Hence if you close also, then it will burn. No problem. But generally oxygen is required for burning any things. But here gas will burn. Hence air is not required. In the presence of air also it will burn. Without air also it will burn. But when you will open it, then it will burn in presence of air. Then blue flame will give. That is called oxidizing flame. And when it will close, hole you will close, then air will not pass. Then that time also gas will burn. And that time it is called reducing flame. Yellow type of flame you will get. Then here I am talking about the blue flame, oxidizing flame. Then here, if we can say this alkali metals and their salts impart, means gives, impart characteristics color to an oxidizing flame. This is because the heat from the flame excites the outermost orbital electron to a higher energy level. When the excited electrons back to the ground state, there is a emission of radiation in the visual region. Okay, that's why it will how much energy they have absorbed. Actually it will go, electron will go at higher energy level, and when it will come down, then how much energy they have absorbed, accordingly when it will come down, they will release energy, means radiation, and they will show different color, because when it will absorb the heat, then that heat will have different, you can say, wavelength. Every wave has a fixed color. Every wavelength has a fixed color. Then how much light they have absorbed, means a certain type of wavelength it will absorb. Heat it will absorb, means wavelength it has absorbed. Then every wavelength has a specified color. That color it will show when it will come from higher energy level to the ground state, means lower energy level. Then here I am telling you few example. I will tell you lithium. It will show crimson red color. crimson, crimson red color. Okay, and its wavelength in nanometer I am talking about. Nanometer is very, very small, 10 to the power minus 9 meter is equal to 1 nanometer. 10 to the power minus 9 meter, which is very less distance, very less, that is equal to 1 nanometer. Then its wavelength crimson red, its wavelength is 670.8 nanometer. Okay, if a metal atom will absorb this wavelength, then it will show crimson red color. And if this is for lithium, it happens in the case of lithium. And sodium will show yellow color, yellow, golden yellow. Then what is its these things? Wavelength? Then 589.2. 589.2 wavelength. Sodium will absorb 589.2 wavelength. Then it will show yellow color. Okay, every atom has, they will absorb energy as per their requirement. Okay, and that type of, you can say, color it will show. Potassium now, potassium situation is different. Then here it will show violet color in oxidizing flame. All are in oxidizing flame. Then here, what is its these things? It requires more energy. No, that wavelength more means energy less. Okay, more the wavelength, less the energy. Keep in mind, more the wavelength, less the energy. Frequency is reverse case. Less frequency, if wavelength is more means energy is less. Okay, and if frequency is more means energy is more. Correct? This you keep in mind, that frequency and wavelength has a inversely proportional. That wavelength is more. Actually, frequency will tell about the energy. Okay, frequency is directly proportional to energy, frequency. Then wavelength, long wavelength means less frequency. Long wavelength means less frequency. Short wavelength means more frequency. Okay, then wavelength, here you can see now it is 768, more wavelength, then energy will be less. Okay, then here you have seen that now it's a lambda value is 768.5 and it will show violet color. Okay, now rubidium, it will show red violet. Then its this wavelength is 780, and cesium is blue color. Cesium will show blue color, and its, we can say, wavelength is small. That is a 455.5 nanometer. Okay, wavelength is here, you can say, less wavelength. Okay, then its this will be, color will be blue. This is actually very, very important in examination. It is asked color of the alkali metals. Even for the other metals also they will ask in oxidizing flame. Okay, this I have told you about the color, which is very, very important. Alkali metals can therefore be detected in lab. This is all very, very important. by flame test you can tell given salt is what type of salt you got. In examination, practical examination, you have to find out what is the salt given to you. Then in flame test will be confirmatory test. If they will show this type of color, then you can tell, you can confirm it that the given salt is of this atom or this metal. Okay, in a lab it is very, very important. Alkali metals can therefore be detected by their respective flame test and can be determined by flame photometry or atomic absorption spectroscopy. If you want, if first you will find out whether what type of atom is there, what type of metal is there. When you will come to know, okay, it is a sodium, then how much sodium? In the lab what you are doing, that is generally, that is the qualitative test, quality, that which salt is there. But now if you come to know, okay, potassium is there or sodium is there or calcium is there, then after that how much is there, then that is done by the, you can say, this thing, photometry, flame photometer or atomic absorption spectroscopy one instrument is there. Then there, by that, by the use of that photometer or atomic absorption spectroscopy, you will come to know the quantity. That is called quantitative test. Qualitative test, only quality, okay, this is present. But how much is present? For that, quantitative test is done. Quantity, how much? Then that is done by the photometry or atomic absorption spectrometer. This question is also asked. These elements, when irradiated with light, then light energy absorbed may be sufficient to make an atom lose electron. Means whenever light radiation will be given to the metal atom, then it electron and the outermost solid that will come out. Okay, this is the main thing. These elements, I am talking about the particularly alkali metals. This happens for the group 2 also, other also, same things. Then these elements, when irradiated with light, when light will come on them, the light energy absorbed may be sufficient. That energy will be sufficient to make the atom lose electron. Okay, they will lose the electron. That's why when you will use the any atomic absorption spectrophotometer or flame photometer, then you have to fix the first wavelength, you have to fix the suitable wavelength, you have to fix the, because wavelength fixed means you are supplying the suitable energy, heat, which is required to remove the electron. Okay, then there will be facilities. Just like any heater, that this will fix. If you want 20 degree, then 20 degree fix. If you want 30 degree, 30 degree fixed. 50 degree, 50 degree fixed. 60, 80, 90, 100, 110, 120. Like that way, it will be fixed in heater. Same way here in photometer, atomic absorption spectrophotometer, wavelength, you have to fix it, suitable wavelength as per requirement. Then that will supply the heat, and by that heat or radiation, you can tell that will be suitable to remove the electron. This I have told you, very, very important things. Okay, this property what I have discussed now, this property makes cesium and potassium useful as electrodes in photoelectric cell. Photoelectric cell, photo means light. Photo means light. Then these properties means after supplying the radiation, electron will be ejected, means go outside. Then this properties makes cesium and potassium useful as electrodes in photoelectric cell. It is actually used in any cell. Electrodes are used, suitable electrodes. Then in photoelectric cells, these cesium and potassium metals are used. Then there it is useful. Okay. Now I am going to discuss some can say, I think it fully it will be not finished, chemical properties. Okay, chemical properties. Now I think next class I will discuss. Okay, because it will take more time. Then today I am stopping only here. Chemical properties of the alkali metal I will discuss in the next class. Thank you.